Today we're doing 7.7 and we're going to talk about scale drawings, and we're going to keep using proportion, so you need to keep that in mind as you go through this lesson. The first definition that we need to get down is scale drawing, and it's going to be a two-dimensional, so it's a flat drawing that accurately represents an object. So for example, if we were going to draw a building, it would be scaled down but have accurate measurements. The next definition is scale, and this is what you use, so it gives the ratio of the dimensions in the drawing to the dimensions of the object. So how can we go from the drawing to the actual object, or vice versa? So this right here is an example of a scale. So if you see this 1 to 20, it says 1 unit on the drawing to 20 units in real life. So they're saying that 1 will represent 20, or another one is 1 centimeter represents 1 meter. Another example is 1/4 of an inch equals 1 foot. So 1/4 on the drawing is 1 foot in real life. So what we're always going to use for every single one is we're always going to use the ratio of the scale over the actual. So this is going to be super important when creating your proportions and your ratios. You always do the scale on top and the actual dimension on the bottom. So let's try a couple of these. So this first example says the length of an object on a scale drawing is 5 centimeters and its actual length is 15 meters. The scale is 1 centimeter to how many meters? What is the scale? So remember, we're always doing scale over actual. So what we can do to start with is it tells us that the scale drawing is 5 centimeters and its actual length is 15 meters. So we can do 5 over 15. And we can include in here the unit. And we're going to say that this equals because it is in proportion. And it says the scale is 1 centimeter. And since centimeters are on top, we're going to put 1 centimeter on the top, and this we don't know, so we put an X. So this is what we're going to solve for, and we're just going to use cross multiplication as we have been doing to solve for X. We have 5X equals 1 times 15, which is 15, divide by 5. So X equals 3. Now if this is in the denominator, we have to use the denominator unit, so 3 meters. So I want you to try this second example down here on your own. So pause the video and play it once you have your answer. So what you should have done is it says the length of an object on a scale drawing is 3.5 inches. The scale is 1 inch to 12 feet. What is the actual length of the object? So again, we're always going back to scale over actual. So if you want, you can start off by setting up your proportion. And in this example, they're giving you the scale. So we know that we have 1 inch, and that represents 12 feet. And they're also telling that the scale is 3.5 inches. So remember, your other clue is that you should have inches or the same unit on top. So since we're solving for the actual length, our X is going to go in the denominator here. And we're still going to cross multiply. So we can say X equals 3.5 times 12. And when you do that, you get X equals 42. Since this is in the denominator, we want to include feet. Now when you're doing this in your homework, I want to see you using algebra. So including that variable in there, that's super important, so you need to keep up with that concept. So there are 2 more definitions that we need to get down. The first one is reduction, and this is in a scale drawing that is smaller than the actual object. So for example, if I give you a building and I ask you to draw a scale drawing of it, your drawing would obviously be smaller than the building. The second one is enlargement, as a scale drawing that is larger than the actual object. So if I ask you to draw a bug, and I want it to be on a larger piece of paper, you can draw that bug bigger than what it is in real life. So let's try a few more examples. This one says if a wall and a 1/4 inch scale drawing is 3 inches tall, how tall is the actual wall? So we can say that we know that 1/4 is also going to be 0.25 inches. And we're going to continue with doing our scale over our actual. So that's what we're going to keep doing. So we can create our two proportions here. And we know that this is our scale because it tells us our scale. So we're going to put 0.25 inches here. We also know that in the drawing it is 3 inches tall. So our 3 inches would go here. So now we have to figure out the bottom. And since it tells us how tall is the actual wall, this is going to be our unknown. And if you think about it, when we measure feet or walls, we usually do this in feet. And if you also think about it, we know that there are 12 inches, which equals 1 foot. And if you multiply 12 by 0.25, you get 3 inches. So this has to be 1 foot because, again, if you multiply those out, on top you get 3 inches. So now it's just like you were doing before where we can cross multiply. We got 0.25x equals 3. So we're going to divide by 0.25 on both sides. So x ends up being 12, and we need to include our unit of feet. So it wants us to try the same thing. So how tall is the wall if a 1/2 inch scale is used? So we're going to start the same way. We're going to create our proportions. We're always doing scale to actual. So now we can say 0.5 inches. And again, we're using the scale of 3 inches. So we also know that this is also going to be 1 foot again. And this is our unknown. So we're just going to cross multiply. So 0.5x equals 3. Divide by 0.5. So you get x equals 6 feet. So at this point, you can now start your exit slip.